Hello, my name is Keith Wiley, and this is my presentation, Why a Whole Brain Emulation from Your Preserved Brain is Probably You. So this talk is focused on the recent awarding of the Large Mammal Preservation Prize by the Brain Preservation Foundation. So this is basically a talk about specifically an attempt to emulate and ultimately upload a mind that is put into a preserved stasis and then scanned from that state. There are other kinds of mind uploading sort of thought experiments, but this presentation is about how we would perform whole brain emulation and perhaps uploading from a preserved brain. So here's one way of defining these terms. Whole brain emulation consists of building a functional model of a specific brain, whereas interpreting a whole brain emulation as a preservation of an individual's personal identity is called mind uploading. So mind uploading is sort of an issue of interpretation. Another distinction here is that whole brain emulation is a technical issue, concerns physical issues. How do we actually capture the information that represents how a brain is operating, and how do we then engineer and compute and emulate that physical process? Whereas mind uploading is a philosophical issue. This is the metaphysics of personal identity and to some extent mind and consciousness, these other terms. Like I said, one way of looking at it is that mind uploading is a matter of interpretation. If we interpret a whole brain emulation as a preservation of identity, then that is what mind uploading refers to. So what are some of the positions that are held with regard to whole brain emulation and mind uploading? So here is sort of an ordered list from worst to best. So first, there are stances that basically hold that whole brain emulation is actually not technically possible. So 1A refers to a failure in which basically something about the way brains work cannot be adequately captured by other substrates or other computational artifacts. If we attempted to emulate a brain, it would just sort of not function properly at all. Now 1B is a slightly different failure. We can imagine perhaps a scenario in which we are able to emulate a brain computationally, but its behavior sort of is unconvincing when it comes to emulating an individual. We sort of don't feel in our interactions with this emulation that the individual person has survived and continues to exist in the emulation, that various psychological and personality and cognitive traits have not been preserved. Then 2 refers to a mode of failure, which is this idea that you might be able to produce a whole brain emulation which outwardly behaves as if everything works. It has the behavioral mannerisms of not only of a human brain, but of a specific human brain. It seems to have successfully captured an individual person, and yet the concept of philosophical zombie proposes that perhaps the whole brain emulation has no inner conscious experience. The third sort of position here, moving toward more optimistic or more accepting stances, Number 3 here refers to the stance that a whole brain emulation does work. It is capturing human-like traits. It is actually capturing the behaviors of an individual, and it is also conscious. It's not a philosophical zombie, but it only represents some sort of identity copy. We say that a whole brain emulation in this third point hasn't actually preserved the original person's identity. The identity has still been lost. The person has still died, and the emulation represents a new identity. Then the 4th point here is where we finally are able to accept whole brain emulation as a successful preservation of identity, meaning successful mind uploading, but only under certain circumstances. So if the procedure is performed in some ways, such as the popularly described gradual in-place replacement, then we might say that identity has been preserved. But if it is performed in other ways, such as a scan and emulate procedure, which is discontinuous, and operates on a brain in stasis, then we might say, no, that wasn't good enough. The identity died and was lost, and the emulation has produced a copy. And then finally, the 5th point is sort of the most optimistic or most accepting position, which would say that any whole brain emulation that seems to technically work, captures human traits, captures an individual person's traits, exhibits that individual's personality, is not only conscious, but also represents a preservation of identity of a particular individual, irregardless of what procedure was used to generate the whole brain emulation. So that would be successful mind uploading in any case there. In my talk, I don't address the first two, either technical impossibility or philosophical zombies. The second one is sort of, we can't actually get at it. There's no way to test for lack of inner consciousness, so there's no point discussing it. And there's no point discussing it here at any rate in this talk. And the first one, technical feasibility, is just sort of out of the scope of this talk. How to actually technically emulate the brain is a topic for a different talk. Consequently, so the preservation of identity is really the consideration here, not technical challenges. And ultimately that means that only this issue of producing copies is the real problem that we're debating. So I refer to this as the copy problem of whole brain emulation or of mind uploading. This fear or concern that what you get is an identity copy and that identity is not preserved. And I consider the copy problem to actually be a philosophical misnomer. I think that it is misunderstanding the nature of identity in a certain way. And it is one of my goals in a lot of my writing and a lot of my speaking to try to convince people that this copy problem issue is not very well posed. So how might we actually emulate a brain? Here's from a preserved brain. So here's the basic approach here. We need to scan the preserved brain. The most likely method would be to slice the brain up into two-dimensional sections and take two-dimensional images and then reconstruct a three-dimensional structural model of the connectome. Also, the connectome is how all the neurons are synaptically connected to one another. Once we have this model, we then essentially functionally run or emulate the model somehow. And there are two broad ways in which we might categorize these emulations. 3A here refers to a system which emulates the model in a purely software system, some sort of supercomputer. You can see 3A here as a demonstrate an example. But it doesn't actually have any physical computational structure that mirrors that of the original brain. As opposed to 3B, where we can imagine that the emulation might be reconstructed into some sort of technical artifact, like a sort of a robot's brain from many science fiction examples, where the brain is sort of in its science fiction manner presumed to actually have a physical network topology that is somewhat akin to the brain's physical topology. And I bring this up because some philosophers care about this distinction. They would say that a pure software emulation is probably producing something like a p-zombie, but that a physical computer network at least has the potential for successful conscious emulation, identity preservation, and ultimately full-blown mind uploading. Other philosophers don't care at all about this distinction. And what are the ways in which we might fail to preserve identity from a whole brain emulation? This talk is going to talk about four possible ways. The concern that the emulation is imperfect, the concern that various continuity streams, either conscious experience or neural activity, are broken, the streams are broken and then restarted in another fashion. The concern of how identity spatially relocates from the brain to the emulation's physical system, the computer, and the concern of reduplication, which is a sort of an odd term from philosophy of mind, which is more commonly known as non-destructive uploading or non-destructive emulation. In all cases, remember, we're really sort of considering the copy problem here, not technical problems. So we're not, especially in number one here, there might be some confusion as to whether we're considering the possibility that an imperfect emulation is not really working in a technical sense, and that's not what we're talking about here. It's presumed that the emulation is in fact technically capturing the underlying neural functionality of the brain and the cognitive, psychological, and personality traits of the mind. Rather, there is this sometimes proposed challenge that if an emulation is not sufficiently perfect, even with the sort of personality seemingly intact, that only the identity is what has been lost, and that a new identity has been born. So again, we're only looking at the copy problem in all of these cases. So we'll just go through them one by one. So this first concern, imperfect emulation, arises when some people say that they demand a perfect sort of scan of the brain, even quantum mechanical in nature, before they will allow a judgment of identity preservation. So they basically want literally the quantum mechanical states of every single particle in the brain to be captured, and before they would consider an emulation to represent identity preservation. An odd thing here is that these people are not always actually against mind uploading. They just have this requirement of quantum mechanical precision. And the funny thing about this is that the Heisenberg uncertainty principle already rules out sort of their hypothetical requirement. You can't create a quantum mechanically precise scan. You can't, detect the location and the momentum of a particle. So these people who would allow judgment of identity preservation if quantum mechanics could be satisfied, but are still sort of on board with the idea in general, are sort of in a bind. I don't think that the requirement can be met. It's probably better for them to just conclude that on the basis of their quantum mechanical requirement, what they really believe is that identity preservation is just impossible anyway. Alternatively, they could abandon the quantum mechanical precision requirement, which is what I propose here. There really isn't any clear evidence that our sort of abstract psychological characteristics, which are then driven by underlying sort of neurophysiological behaviors and functions, that any of that really relies on the absolutely microscopic quantum mechanical effects going on inside the subatomic particles of the brain. There's really just no good reason to assume that yet. In fact, to the contrary, our brains appear to be damaged in these ways on a continual basis. The radon in the air we breathe, cosmic rays, bricks and bananas and X-rays. The reason that a technician leaves the room when they give you an X-ray is that even with a lead vest, there's radiation leaking around the room. All of these forms of radiation certainly have the potential to occasionally transiently irradiate a subatomic particle in your brain and shift its quantum mechanical state in some fashion. And yet we don't judge these everyday effects to represent an erasure of our identity. There are also sort of much larger scale damages that occur to the brain. Concussions and cortisol generated by our body in response to stress, and aspartame, curiously enough. Some of these effects can actually kill whole neurons at a time. Clearly, if a neuron dies, then all of the quantum mechanical subparticle states that were inside that neuron were obviously obliterated along with the neuron when it died. And yet, we still don't deem these sorts of cases as identity erasure and new identity invocation out of nothing. We just don't regard one another or ourselves in this fashion. So there's something really contradictory here about requiring quantum mechanical precision to allow sort of a judgment of identity preservation, and yet tolerating in our everyday lives all sorts of damage, both subatomic and at a much larger scale. It's going on all the time. I think this contradiction really needs to be squared before this quantum mechanical argument can be taken seriously. Another response to this quantum mechanical issue is to this quantum mechanical sort of requirement and challenge is to look at the technology of magnetic resonance imaging. So this is a technology that is used to take images of, or even videos of a brain. In the fMRI sense, functional magnetic resonance imaging, it's actually used to produce almost real-time videos of what parts of the brain are active in response to certain stimuli and tasks. And fMRI somewhat sounds a little hokey to put it this way, but it's actually a quantum mechanical technology. It uses magnetism to manipulate certain quantum mechanical states of the brain, specifically the spin angular momenta of the hydrogen nuclei of our of the water of our red hemoglobin cells. These spin angular momenta are also called proton spins. So fMRI magnetically brings all of these states into alignment and then releases them. If our personal identity depended on those same quantum mechanical states that fMRI, if personal identity depended on the states that fMRI is fiddling with, then fMRI would be a metaphysical identity erasure machine. The person who enters an fMRI would vanish, and some copy would come into existence suddenly. So one possible response to this fMRI sort of counter argument to the quantum mechanical identity theory One response is to say that, well, MRI isn't obliterating all of the quantum mechanical states, so maybe MRI is only affecting the ones that don't really matter, but the quantum mechanical states that are critical to identity are the ones that MRI wasn't changing anyway. But that's somewhat that's a rather fortuitous argument. We're basically saying that when we invented MRI, we were just spectacularly lucky and sort of naive to have invented a machine that might have sort of accidentally been an identity erasure machine, and we just sort of luckily kind of missed the mark on that. Which I think is sort of a weak argument to say that the reason that the MRI argument doesn't successfully counter quantum mechanical identity is that it was just sort of naively lucky. Also, it's worth pointing out that we couldn't possibly know. How are we going to know whether MRI is erasing our personal identity or whether it is not erasing our identity? This is sort of an impossible question to address. So instead of assuming that we dodged a bullet when we invented MRI and that it just sort of luckily only affects the QM states that aren't relevant to identity, a more reasonable conclusion of all this is that quantum mechanical identity is probably just not a serious proposal in the first place. And finally, the fact that there's no way to really detect or measure or much less falsify this idea. We can't really figure out which quantum mechanical states are having some tangible effect on our identity and which ones aren't. Makes all this an unfalsifiable theory. We can't really do anything about it, which means we should probably not take it too seriously. So the next objection is about continuity streams. So the first one is stream of consciousness. People sometimes say that they want their waking conscious experience to represent some sort of unbroken stream. And if our consciousness ever sort of ceases and then restarts, then our identity has vanished and a new identity has popped up. And clearly, in the case of brain preservation, this would not count because a preserved brain is an absolutely static physical object. It clearly has no inner conscious experience because it's undergoing no dynamic sort of experience or evolution at all. So, according to a stream of consciousness requirement, clearly the identity that was originally associated with the brain has vanished and a new identity has been invoked when you create an emulation of that brain. In response to the stream of consciousness requirement, it's worth sort of realizing that we already undergo various degradations in our conscious sort of level of conscious awareness. We fall asleep, we faint and pass out, we undergo medical general anesthesia, and in a few rare medical cases, someone undergoes rapid frigid drowning, in which they literally drown in an almost frozen lake for upwards of an hour, where the cold temperatures actually prevent their body from decaying for a brief period of time, at least long enough to get them to a hospital, and they have survived the experience. The judgment is not that in any of those cases our identity has vanished. When confronted with this counterargument, the stream of consciousness sort of line of thought usually pivots in a very predictable manner. It wasn't really the consciousness stream that they were concerned about. What they really meant was basal neural activity. They want the brain's physical neural function to be an unbroken stream of function, and if this sort of collective neural activity were to ever cease and then start again, then the metaphysical identity would again sort of vanish from the original, and a new identity would crop up when you restarted the neural activity. And again, of course, the judgment must be that although the brain is clearly being brought to a very low level of activity in the examples from the previous slide, general anesthesia and rapid frigid drowning, the brain is certainly still in a somewhat living and metabolic state in those cases, and we just judge that it did not drop below the threshold where identity would be lost. But again, there's a concern that a true brain preservation in its really static state is going to turn off too much activity in the brain, and that we will judge it as an identity loss. So the problem with the basal neural activity requirement is this threshold. How are we going to ever determine what this purported threshold is? What is the threshold of brain activity below which abstract metaphysical personal identity, this incredibly abstract sort of philosophical concept, What is the neural threshold of activity below which this identity concept undergoes some sort of metaphysical vanishment? And if you were to then bring the brain's activity back up past the threshold, this metaphysical identity would reemerge, but it would be a brand new one. What kind of medical, neurological, sort of brute physical threshold of activity could be correlated with something like metaphysical identity? And how could we ever determine what it is? How could we ever find such a threshold? How could we ever judge that we had dropped below the threshold, or that we had successfully, sort of dropped to just above the threshold and come back with our identity intact? How can we ever do any of this? It really seems sort of entirely outside the realm of physical sort of measurements. And again, so this is starting to sound kind of like what I said earlier. This feels like an unfalsifiable claim and phenomenon. This threshold of neural activity is not scientifically approachable. And as I suggest here, perhaps the best conclusion to a totally unfalsifiable claim is that we should just not worry about it. Another problem is that it prescribes very strange behavior. It suggests that we should point to a person, perhaps a patient from a rapid frigid drowning medical emergency. We should point to them, and we should declare literally what we see written on the screen here, this preposterous statement, that this person, according to my personal criteria of neural activity, has undergone a travesty in which their brain dropped below my acceptable neural activity threshold. So now that person is a copy, and you have to treat them as a copy, and I think they should even regard themselves as a copy, and that's how we should all treat this person for the rest of their lives. And my point is that I just don't think it's very realistic. I don't think most people would treat each other this way, because they would have no indication that they should. When general anesthesia was invented, no one came along and said, okay, maybe we're erasing our identity. When the first rapid frigid drowning patient was revived, no one looked at that person and said, gosh, I don't know, I wonder if their identity is sort of gone and this is a new person. We don't really have any good reason to start that conversation. So examples like the quote shown on the screen here aren't really very realistic in my opinion. Consider this hypothetical scenario. Let's say we determine that 50 degrees Fahrenheit is the threshold of identity preservation. If your brain drops below 50 degrees, the brain shuts down too much and we lose our identity. So Alice drowns in a lake and she arrives at the hospital and her temperature is 52. So she didn't descend below the threshold, and the doctors revive her and she lives a long life. But years later, the equipment is calibrated, and we discover that actually her temperature had dropped to 48 degrees all those years ago. And she's lived her entire life with everybody holding the wrong position about her identity. Even she has the wrong sort of belief about her identity. After all, the doctors told her, she came back from 52 degrees, so she herself believed that she was the original identity, and she was wrong, apparently, according to this theory. And my point is simply that this example shows that this concept of a threshold and how we should regard it, and how we should regard each other in response to such a threshold, I consider to be fairly unrealistic. So the third objection is this issue of spatial relocation. It is asked how the identity, which is, I suppose, it is thought to be kind of rattling around inside your skull or something. It's got to get sort of through space over to wherever the emulation's physical substrate is, the computer. How's it going to get over to the computer from your head? I find this question somewhat ludicrous, but it does come up, and we have to sort of figure out how to meet it because people seem to be concerned about it. However, I do think that one of the first responses is to just quickly turn the question around, even if it won't sort of convince anyone. I think it's worth asking why we have to take the question seriously. Why do we have to explain how identity moves through space, instead of demanding that it be explained why it should be subjected to physical traits like spatial coordinates and motion in the first place? It seems reasonable to put that on the table and say, no, wait, if you're going to propose that identity has to move through space, then you have to address everything that suggests, such as what sort of motion is identity subject to? Does identity have the traits of mass such that it has to accelerate smoothly? If there's a wall between the brain that is being scanned and the computer that is going to take the emulation, does it actually have to bank around a corner to get through space to the emulation? If it's in a strong gravity well, does identity sort of dip down? Now I realize that this sounds facetious, But I'm not actually trying to come across sarcastically. I'm saying that when it is proposed that identity has to move through space from one place to another, that these are exactly the kinds of questions that arise. If we're going to take identity's location in space and movement through space seriously, then we have to consider all the other things that would be imposed upon it by being a spatial concept or entity. And my point is that not sarcastically, I just think this all sounds sort of silly. I think that identity simply doesn't work this way. Identity is not physical or spatial in the first place, and that's why we don't have to worry about how it moves through space. So this has been considered at depth, for quite a while. Derek Parfit, in his famous book Reasons and Persons, and other philosophers have, asked this question: is identity sort of a physical concept or an abstract or pattern or informational concept? So if it's a physical concept, we refer to that as body identity, where an identity is associated with physical things, such as bodies or brains. Alternatively, with respect to the identity of people, which we call psychological identity, where your identity is indicated by cognitive personality traits, not a physical thing such as the brain. And this is sort of an open question in philosophy. All the proposed models of identity can be challenged. Body identity has its weaknesses. Straightforward psychological identity has its challenges, although variants on it, I think, are some of the stronger versions. But this is where this distinction comes up, is that some people have a more body identity inclined philosophy, and that's why they're worried about how identity moves through space. And other people have a psychological identity model where identity is a cognitive aspect of a person's personality, is this abstract thing, and that's why concerns about location and motion through space by identity don't really make sense to people who subscribe to the psychological identity position. So one way to look at this is that we already know that the brain is trading out its material components on a regular basis. This is often alluded to the ship of Theseus sort of thought experiment. Sometimes people think this isn't the case because it's sort of colloquially well known that neurons don't die off or get reborn too frequently in the adult brain. There's some research to indicate there might be some of it, but certainly not a whole lot. But I think some people erroneously think that means that the brain is sort of physically sort of undergoing a change. All that means is that the neurons themselves are undergoing sort of a ship of Theseus style interchange of molecular components. After all, that's what metabolism is essentially doing to a significant degree. So if this gives strength to the theory that it's not really the physical components that are carrying the identity, it's something about the pattern and way in which all these material aspects of the brain are connected up. So this leads us toward the psychological theory, the pattern theory of identity. But as I say here, patterns again are non-spatial. They don't have locations. They don't move. Curiously, they can multi-instantiate. So you can have a pattern for which there are two physical systems. In philosophy, a physical instantiation of one of these things called a token. You can have two tokens that instantiate the same sort of abstract concept, which is a type. This is sort of what you get when you take a pattern or an informational or abstract approach to identity. So if identity is not subject to physical and spatial traits anyway, sort of as perhaps somewhat argued by the interchange of matter that the brain is always undergoing, then all the spatial location questions, how it moves from the brain to the emulation, all that challenge just kind of goes away. In fact, I consider this to be something of a category error, where you assign traits of one category to a member of another category. So in this case, physiospatial traits of location and motion have been incorrectly imposed upon something which is not physiospatial in the first place, which is a sort of personal identity. Another response, which Randall and I wrote up in a paper, starts with the recognition of the fact that many people do actually accept the gradual in-place replacement procedure as preserving identity. So this is the procedure, hypothetical, of course, a thought experiment, in which the neurons of the brain are slowly traded out one at a time by microscopic computational prosthetics. And many people believe that if you did this, the resulting physical artifact inside your skull, this computerized system, would represent an emulation and also an upload and a preservation of identity. It would have worked in all the intended ways. Whereas the scan and emulate approach, where we take a frozen or preserved brain, scan it, and build an emulation from that in a discontinuous fashion. These same people who accept gradual in-place replacement will reject scan and emulate as destroying identity and producing a new one. And this is sort of the premise from which our paper starts. So we consider a spectrum of procedures where gradual in-place replacement is at one end, scan and emulate is at the other, and in the middle there's this third procedure, instantaneous in-place replacement, with two sliding scales sort of tying the three procedures together. And our argument proceeds first by showing that scan and emulate differs from instantaneous replacement only by the distance over which the procedure is performed. So in an instantaneous replacement procedure, the distance is on the order of microns. You take this, it's not zero, incidentally. It's not that instantaneous replacement is truly in place. It's just in place within the skull, which is sort of a meaningless point of importance, in my opinion. You take your prosthetic neuron that is going to replace a neuron and you put it kind of next to the neuron, and then it observes and learns the neuron's function so that it can emulate it, and then at some later time the biological neuron is killed and the prosthetic takes over the role. But the prosthetic did not actually occur in the same location as the neuron. It occurred next to it. So we can say that the role or responsibility or ownership of that neuron's functional behavior has been reassociated across a few neurons of space, across a few microns of space to the prosthetic. So there's still a non-zero distance. And in the case of scan and emulate, that distance is significantly larger. Of course, it's perhaps on the scale of meters. If the brain that is being operated on is on one side of a room and the computer that will take over responsibility for the emulation is on the other side of the room. And we question, what difference does this distance make? If there were some distance that were of relevant difference, how do we make sense of the apparent threshold of distance where there are profound metaphysical differences in interpretation? The second step of the argument ties the other two halves of the spectrum together. Gradual in-place replacement and instantaneous in-place replacement are associated with one another by showing that it is merely a sliding scale of replacement rate. If you gradually replace 100,000 neurons a second, then you can finish the job in about 10 days. And if you replace them at a rate of 100 billion per second, you can still say that it's being gradually performed over the period of 1 second. But we could actually extend this right up to sort of to the limit of the reasoning. We could say that all of the prosthetics are injected into the brain. They all find their host neurons and learn their functions, but they don't take over the role yet. And then with a single global switch from the outside, all the prosthetics take over, and the biological neurons are killed, all in the exact instantaneously same moment. And again, the question is, what difference does this sort of sliding threshold replacement rate make? Any viewers who are sort of coming up with counter arguments to this, sort of as you see my off-the-cuff presentation here, I encourage you to actually look at that paper, which goes through this in fastidious detail and really questions whether these proposed thresholds really would make any sense. The final step of the argument, of course, is to point out that what we've done with the first 2 points of the argument is tie all 3 of these together. So we should actually judge gradual in-place replacement with an equivalent identity status to that of scan and emulate. It's essentially a fallacy to judge the 2 of them differently. And we can quickly say, well, what should that judgment be? Maybe we should just say that gradual in-place replacement is actually not preserving identity either. But alternatively, of course, first of all, that's not really the goal anyone's shooting for. We want to believe that these procedures can work if they are performed correctly. And a good point of evidence in favor of that is, again, to come back around to the recognition that the brain is undergoing ongoing gradual replacement all the time. Anyway, it's not replacing neurons, it's replacing molecules, but so be it. Our identity seems to survive sort of physical trade-off of matter. So that gives good reason to believe that identity can be preserved in these cases. And the fourth challenge is this issue of reduplication, which is, again, it's a term that doesn't come up too often, but it means exactly the same thing as non-destructive emulation or mind uploading. So let's consider a procedure where we can preserve a brain and then scan the connectomic structure out of it without slicing it up. Some sort of X-ray or MRI or PET-like or MEG, some sort of scan, or some futuristic extrapolation of a brain scan is able to glean the three-dimensional structure without actually damaging the brain. We could then proceed to create a whole brain emulation again, just as we would have. But of course, now we can revive the brain. If the entire body was actually preserved, we can essentially wake up the person. And this is the philosophical question that reduplication poses, or that non-destructive uploading poses, is what happens to the identity in this case. And a frequent judgment is that in a non-destructive case, the identity that we care about, the quote original identity, remains stuck with the biological brain, and that again some sort of copy springs up in the emulation, and that we should judge the whole thing as a complete failure to transfer identity to the emulation. Although, of course, in this case, it isn't really so much a question of survival or death of the identity, because we actually did revive the original person. But nevertheless, the question of whether identity has been preserved into the emulation is sort of the question at hand here. But if identity lacks physical traits like location anyway, then to say that identity is sort of inside the biological brain, it is wrong, sort of out of the gate. We need to stop thinking about it that way. If we take the pattern approach, or in philosophy of realism, if we take the type and token approach, then say that the mind or identity is a type, and it is instantiated by some physical token that embodies the necessary patterns of that identity in mind, then all the tokens, all the physical systems that hold the correct pattern, physical pattern that underlies that mind and identity, all those tokens are successfully doing the job equally. So the identity in question should be just as equally associated with the emulation as it should be with the brain. That's sort of the consequence of looking at it this way. But that's a good question, though. So what happened to our identity then? So we can say that the identity has been multi-instantiated, but that sort of leaves this lingering question. Okay, well, maybe we're willing to be a little bit less sort of biased about saying that the identity was stuck in the biological system or failed to attach to the emulation. But nevertheless, the question stands: what happened to the identity if we have this multi-instantiation scenario? And the proposal is a theory of identity called branching identity. It relies heavily on this non-physical, non-spatial sort of approach. It's a variant on psychological identity. Earlier I showed that Parfit used the terminology of body identity and psychological identity. Branching identity is a variant on psychological identity, which still basically holds that identity is indicated by the cognitive and personality traits of a person, and not by the physical atom and material components of the brain. Clearly you can tell from the term that what branching identity is claiming is that you can get this sort of other terms come up, are splitting or fission, and all these words sort of come up when you read about this, that an identity can in fact sort of yield two child identities, but that it does so equally. So the way that I like to put this in my own writing is that all of the descendant minds of a common ancestral mind have equal primacy in their claim to the original identity. So what we're claiming is that it is essentially a bald-faced prejudice to grant sort of a greater importance to the point of view and personal report of the mind associated with the brain than it is to hear the point of view of the mind associated with whole brain emulation. And why is it a prejudice? Because it comes back to the fact that we should not be giving any specific importance to the physical tokens in question, the physical components, the brain or the computer in the first place. If the only thing we're going to rely on to indicate identity is psychological characteristics, then those psychological characteristics are equally represented by both systems. That's what branching identity is arguing for. And branching identity has some major advantages. First of all, it respects the point of view claims of the people themselves. There are occasions where we don't actually believe people's own claims about their own state of mind, but we only do that when we have good reason to believe that a person suffers from some sort of psychosis, that we believe that they are essentially mentally ill. But that is, of course, not what we're talking about here. We don't believe that an emulation's claims of its own claims about its identity are wrong because the emulation is in any way mentally ill. In fact, sort of by definition of the terms of the whole debate, the emulation is in fact producing the same sort of thoughts and beliefs and values of the original brain. So any mental illness there would have been in the brain anyway. So we really should take seriously the individual subjective point of view of these people. It helps us avoid bias and prejudice, which is sort of putting weight on bias, and discrimination, which is putting actions on prejudice and actually treating people differently. By honoring branching identity, we minimize the risk that we will behave in these prejudicial fashions. It avoids unfalsifiable phenomena. We don't have to concern ourselves with proposed quantum mechanical aspects of identity. We don't have to concern ourselves with thresholds of conscious or neural activity below which metaphysical identity apparently would vanish. We don't have to worry about thresholds in replacement rate or thresholds in replacement distance. All these things are unfalsifiable. We can't really determine how a metaphysical concept like identity would be affected by them. So they're unfalsifiable claims, and branching identity saves us from having to worry about them. Relatedly, in the fourth point here, it helps us avoid imposing additional properties on our metaphysics. So again, we don't have to impose a quantum mechanical sort of bridge between the physical and the metaphysical. We don't have to impose continuity streams or conscious neural activity thresholds. We don't have to make category errors in our sort of assignment of spatial properties to identity. And we don't have to make determinations about arbitrary replacement distance and rate thresholds. And finally, branching identity often, in as many cases as I've been able to find, handles the paradoxes that come up in these thought experiments much more smoothly than the other theories of identity. So I gave just one example of Alice, who had a rapid frigid drowning emergency tragedy, and was brought back, and everyone, including Alice, believed that her identity was intact. But then, paradoxically, it was discovered later in life that everyone, including Alice, was wrong. They held the wrong position about her identity, and somehow Alice held the wrong position about her own identity. Again, if you sort of take a branching identity approach to these things, these paradoxes tend to go away. My book actually has a large collection of these paradoxes and interesting thought experiments in general that crop up when we think about mind uploading. So in conclusion, sort of based on the line of reasoning that has been proposed in this talk, if you buy it, then there is good metaphysical reasoning to judge that a whole brain emulation of a scanned and preserved brain truly preserves identity and represents survival of the person involved. In other words, it represents true mind uploading. Thank you very much.